Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. In this lecture today I am going to discuss about the exact differential equations and problems on it. These are the topics today I am going to discuss. The sufficient condition for exactness, general solution for this exact differential equation and problems on this. So first let us see the definition of exact differential equation. Let m of x comma y into dx plus n of x comma y into dy equal to 0 be a first order and first degree differential equation where m and n are this real valued functions for some x and y. Here I am writing m of x comma y denotes m is a function of x and y. Similarly, n is also a function of x and y. Then this equation m dx plus n dy equal to 0 is said to be exact differential equation if there exists a function f such that if you differentiate f with respect to x partially, you have to get m dou f by dou x equal to m, and you differentiate f partially with respect to y, dou f by dou y equal to n. This is the actual definition of exact differential equation. Now let us see what is the condition for exactness. When do you say that this equation is exact? Here m and n are two real valued functions which have continuous partial derivatives. Then the necessary and sufficient condition for this differential equation m dx plus n dy equal to 0 is exact. Is this condition dou m by dou y equal to dou n by dou x. Here m is a function of x and y, so you differentiate m with respect to y. N is also a function of x and y, so you differentiate n with respect to x partially. Both should be equal. Then we say that this equation is said to be exact differential equation. Now we know how to check whether the given equation is exact or not. Okay, once it is exact, how to find the general solution? Once this differential equation is exact, that is dou m by dou y equal to dou n by dou x, it is satisfying. Then we write the general solution as integration of m into dx treating y as constant plus terms in n which are independent of x, means free from x, into dy equal to some constant c. This is the formula to write the general solution for the exact differential equation. Integral m dx plus n dy equal to c. First term y terms are constant. In second term ignore x terms, only consider purely y terms, and this gives the general solution, right? Now let us see one problem. Solve this equation e power y plus 1 into cos x dx plus e power y into sin x dy equal to 0. Now let us compare this with this equation m dx plus n dy is equal to 0, right? So dx coefficient, consider it as m. Here what is m here? E power y plus 1 into cos x, and dy coefficient you take it as n. So n is e power y sin x. Now we have written m and n. Now let us check whether this equation is exact or not. What is the condition? Dou m by dou y and dou n by dou x, both the values must be equal. Now let us find dou m by dou y. There is y terms and x terms in m. Now we are differentiating m partially with respect to y. While differentiating m with respect to y, treat x as constant. So here x terms is cos x, it remains the same. E power y plus 1 derivative is e power y. So dou m by dou y we got it as e power y cos x. Similarly, n is given as e power y sin x. You are differentiating n partially with respect to x. That means y term constant. Here what are the y terms? E power y, that is constant. You don't need to differentiate that. Sin x derivative cos x. So e power y cos x, e power y cos x both are equal. So dou m by dou y equal to dou n by dou x. Therefore, the given differential equation, say equation 1, is exact. Once it is exact, we have to find the general solution for the differential equation. So first let us write the formula for general solution. Integration of m dx, make sure that y is constant, this is most important thing, plus terms independent of x in n into dy equal to c. In the second term n, I don't want x terms, purely y terms are there. If you don't have separately x and y terms, take it as 0, right? So integration of m means e power y plus 1 into cos x, where y constant, plus here we can see n is equal to e power y sin x. There is only one term, both x and y terms are together, so I can't ignore x terms, so take it 0. Suppose if you have n is equal to e power y plus sin x, then here I can take it as integration of terms free from x. I don't want this x terms, so you can take e power y dy. But here I can not separate both x and y terms, so ignore, so integral 0 dy. Now integration of e power y plus 1 cos x, we are integrating with respect to x and treating y terms as constant. E power y plus 1 constant as it is, integration of cos x is sin x is equal to c. So this is a general solution for the given differential equation. Now let us see one more problem on this exact differential equation. Solve x into e power xy plus 2y into dy by dx plus y into e power xy equal to 0. This equation is not in the standard form. What is the standard form? M dx plus n dy equal to 0. If the equation is not in the standard form, we have to convert or reduce the equation into this type, m dx plus n dy equal to 0, right? So this can be written as, if you take out this to dx this side, x into e power xy plus 2y into dy plus y e power xy dx equal to 0. Now this is in the form of m into dx plus n into dy equal to 0, where m is y e power xy, n is equal to x into e power xy plus 2y. Now let us differentiate m with respect to y partially, dou m by dou y. Here y into e power xy, let us differentiate this with uv rule. First one is take it as y as u, e power xy as v, y into, what is the derivative of e power xy with respect to y? E power xy into x plus e power xy into derivative of is 1. So if you take e power xy common, this can be written as xy plus 1. Similarly, find dou n by dou x. What is n here? X into e power xy plus 2y. Here also x into uv rule. What is the derivative of e power xy with respect to x? E power xy into y plus e power xy into x derivative is 1 plus 2y. Here we don't have any x terms, we are differentiating with respect to x, so this is constant, constant derivative is 0. So again, if you take e power xy common, xy plus 1, this and this both are equal, so dou m by dou y equal to dou n by dou x. The condition for exactness is satisfied for this, so we can say that the given differential equation is exact. Now once it is exact, we have to find the general solution, right? So general solution, again let us write down the formula for that. Integration of m dx, treating y constant, plus terms not containing x into dy equal to c. So m means y e power xy dx plus integration of, what is n here? X into e power xy plus 2y. I don't want x terms, so you can remove this, only consider this. So integration of 2y dy equal to c, right? So what is y power xy? Integration of y e power xy dx, treating y constant. Here y is not a variable, y is constant. So this e power xy by y integration of e power xy is e power xy by y, because y is constant, plus 2 into y dy is y square by 2, 2 get cancelled. So we got e power xy plus y square equal to c, right? Now let us solve this one more problem. Solve 1 plus e power x by y dx plus e power x by y into 1 minus x by y dy equal to 0. This is very important problem. You always compare this with this equation m dx plus n dy equal to 0, isn't it? So here m is 1 plus e power xy, n is equal to e power x by y into 1 minus x by y. So what is the condition for exactness? Dou m by dou y. You differentiate m with respect to y. What is e power x by y derivative? E power x by y into dou y of again x by y. So e power x by y into minus x by y square, right? So we got dou m by dou y. Similarly, dou n by dou x. Dou n by dou x, that is dou by dou x of, what is n here? E power x by y into 1 e power x by y minus x by y into e power x by y. You differentiate this with respect to x. So we get e power x by y into minus 1 by y plus uv rule, uv dash plus vu dash, 1 minus x by y into derivative of e power x by y with respect to x, that is e power x by y into 1 by y. So we got obviously e power x by y into minus x by y square. This and this both are equal. So dou m by dou y equal to dou n by dou x. So this differential equation we call it as exact. Now let us see the general solution for this first order differential equation. The general solution, you know this formula. So integration of 1 plus e power x by y dx plus terms in n not containing x. I don't find any term which is not containing x terms. So let us take it as 0. So integration of 1 into dx is x plus integration of e power x by y is e power x by y by 1 by y. Say assume e power x by 2 dx. So e power x by 2 by x by 2. Why I am taking x by 2 means to make it clear. So here 2 is constant, here y is constant. So in place of 2, if you can make it y, we get this value. So this is x plus y into e power x by y equal to c. So this is how we find the general solution for the exact differential equation. Next class, let us see how to find the integrating factor for non-exact differential equations, right? Thank you.